Hello learners, this is Dr. Krishnaveni, Department of Mathematics, Maristella College, Vijayawada. In this presentation, you are going to learn about Bernoulli's differential equation. You will see the standard form of a Bernoulli's differential equation and a working rule to solve Bernoulli's differential equation. What is a Bernoulli's differential equation? A differential equation of the form dy by dx plus p of x into y is equal to q of x multiplied by y power n, where n is a real number and n is different from both 0 and 1, is called a Bernoulli's differential equation in y. This equation is similar to that of a linear differential equation. Both in linear differential equation and in Bernoulli's differential equation, the terms on the left-hand side of the equation are the same. They differ only in the term on the right-hand side of the equation. In case of linear differential equation, on the right-hand side, you find only a function of x. Whereas, in case of a Bernoulli's differential equation, the right-hand side you will find not only a function of x, but another function, a function of y power n. This is one of the forms of the Bernoulli's differential equation, in which case y is the dependent variable and x is the independent variable. You see, here is another form of a Bernoulli's differential equation. In this form, x is the dependent variable and y is the independent variable. So a Bernoulli's differential equation is a first order, first degree differential equation having three terms. How do we solve a Bernoulli's differential equation? We solve a Bernoulli's differential equation by reducing it into a linear differential equation. Here is the working rule to solve a Bernoulli's differential equation. Step 1. Reduce the given equation to the standard form. This is the first type, dy by dx plus p of x into y is equal to q of x multiplied by y power n. As I said earlier, you are going to solve it by reducing it into a linear form. So first step is reduce the equation to the standard form. In the second step, you divide the entire equation with y power n. And on dividing with y power n, you get the coefficient of p of x as y by y power n, which is equal to y power 1 minus n. So in order to reduce the equation to the linear form, you replace y power 1 minus n by some variable t. In the second step, you divide the equation with y power n. In the third step, you replace the coefficient of p of x, namely y power 1 minus n by some variable t, so that this equation will be reducing to a linear differential equation in t. So you know how to solve a linear differential equation in t. So solve the obtained linear differential equation in order to get a general solution. And in that general solution, you replace t by y power 1 minus n to get the general solution of the given Bernoulli's differential equation. Let us see the working rule to solve a Bernoulli's differential equation in x. Reduce the given differential equation to the standard form in the first step, and then divide the equation with x power n and replace the coefficient of p of y, namely x power 1 minus n by t. So in the first step, we will reduce the given differential equation to the standard form. In the second step, we divide the equation with x power n. And in the third step, we replace the coefficient of p of y, that is x power 1 minus n by t, so that the equation will be reduced to a linear form in t. Once it is a linear equation, you know the procedure to solve it. Solve the obtained linear differential equation, and in the general solution of the linear differential equation, you replace t by x power 1 minus n to get the general solution of the Bernoulli's differential equation in x. Let us now see some examples. This is the first example. You have a differential equation. Here we have derivative of y with respect to x. This is the first derivative of y with respect to x. And the power of dy by dx is 1. So this is a first order, first degree differential equation. And if you see, this is in the form dy by dx plus function of x multiplied by y is equal to function of x multiplied by y power n. So a Bernoulli's differential equation. Already it is in the standard form. So you are able to identify p of x, that is cot x, and q of x, that is sin square x multiplied by cos square x. So first step, standard form. Second step, identifying the functions p of x and q of x. Now, in order to reduce this equation to a linear form, divide the entire equation 1 with y square. When you divide the equation with y square, you will get this equation 2. And see here, p of x is cot x. The coefficient of p of x here is 1 by y. So after division, you have to replace the coefficient of p of x by some variable t. That is step 3. So coefficient of p of x here is 1 by y. So put 1 by y as t in the equation 2. And on differentiating both sides with respect to x, we get 1 by y square dy by dx as minus dt by dx. So in the equation 2, you replace 1 by y square dy by dx by minus dt by dx. So on replacing, we get the equation 3. Now this is the linear differential equation in T. See, in order to reduce the Bernoulli's differential equation to a linear equation, what we did is we divided the equation with y power n, means y square, and we replaced the coefficient of p of x, that is 1 by y by t. Now you have a linear differential equation in T. So step-by-step process, no? You can proceed with the step-by-step process to solve this linear differential equation. So here dt by dx plus function of x multiplied by t is equal to function of x, which is the standard form of linear differential equation in T. So here P1 of x is minus cot x, Q1 of x is the one which is on the right hand side, minus sin square x, cos square x. So we have to now find out integral of P1 of x, that is log mod 1 by sin x. Then integrating factor would be e power integral p1 of x, which is 1 by sin x. Now we are ready to write the general solution of linear differential equation 3. The general solution is t multiplied by the integrating factor is equal to integral of q1 of x multiplied by the integrating factor plus c. So you have seen the integrating factor as 1 by sin x. Substitute for integrating factor 1 by sin x. Then on integrating, you will get cos cube x by 3. Because this is in the form of f of x power n multiplied by its derivative. So the integral of fx power n multiplied by its derivative is fx power n plus 1 by n plus 1. So now you are able to get the general solution of the linear differential equation, and on replacing t by 1 by y, you get the general solution of the Bessel's differential equation. Let us move on to another example. In this example, if you see, this is again a first order, first degree differential equation. So you just write from this dy by dx is what? And if you see here, there are 2 terms, but in the general form of Bernoulli's differential equation, you should have 3 terms. You cannot split this into 2 more terms. So take the reciprocal of this equation. Means you take the reciprocals of the terms on the left-hand side and right-hand side. So dy by dx reciprocal is dx by dy. Reciprocal of 1 by x square y cube plus xy is x square y cube plus xy. Now you have 3 terms. So you are forced to change the variables now roles. In the given equation, y is the dependent variable, x is the independent variable, whereas now you have a differential equation where x is the dependent variable, y is the independent variable. So this is a second form of Bernoulli's differential equation. In x, this is dx by dy plus function of y into x is equal to function of y into x power n. So you are able to identify p of y, which is minus y, q of y here, which is y cube. So how do we solve this Bernoulli's differential equation? By reducing it into a linear equation. So divide the equation with x square, because in the linear equation in x, you have to have only y, function of y on the right hand side. So you have to divide the entire equation with x square. After dividing the equation with x square, you will be getting an equation 3. Now, in this equation 3, you replace the coefficient of y by some variable t. Coefficient of p of y by t. See, coefficient of p of y is 1 by x. So you replace 1 by x by t. On differentiating both sides with respect to y, we get 1 by x square dx by dy as minus dt by dy. So substituting for 1 by x square dx by dy in equation 3, we get minus dt by dy minus y into t is equal to y cube. So a linear differential equation in t. So you reduced a Bernoulli's equation into a linear differential equation in t. Now, here, this is a standard linear differential equation in t. So identify p1 of y, q1 of y. Find out the integral of pn of y. And e raised to power e integral p1 of y will give you the integrating factor. And write the general solution of the linear differential equation, which is t multiplied by the integrating factor is equal to integral of qn of y multiplied by the integrating factor plus the integrating constant. So substituting for the integrating factor, you get the general solution of the linear differential equation in T. And on replacing T by 1 by x, we get the general solution of the given Bernoulli's differential equation. See, this is a first order differential equation. So the general solution will have one arbitrary constant. Hope it is clear to you. Thank you.